Hello students. This lesson will be about the notes for Chapter 1, Lesson 1, titled Order of Operations and One-Step Equations and Inequalities. First is the order of operations. When you are solving a problem, there is a specific order in which you should perform the mathematical operations in order to obtain the correct answer. You can refer to the completed notes that are also posted on my website for a complete list of the definitions, but we will quickly review them now. As noted at the top, you must follow the order each time, and it is often helpful to check them off as you work a problem. The first thing in the order of operations, you need to look for grouping symbols. Here are some examples of the grouping symbols. We have parentheses, we have square brackets, we have these two straight up and down lines indicating absolute value. These are called braces, and these are used with matrices. Also, there are invisible grouping symbols around the numerator and the denominator in large fractions. You must evaluate everything inside the grouping symbols until you get a single number left inside the parentheses. Once you've completed grouping symbols, you can move on to the next step, which is exponents. Exponents is just repeated multiplication. The same number gets multiplied by itself a certain number of times indicated by the exponent. After exponents have gotten down to one single number, we'll move on to division and multiplication. These are of the same importance. We evaluate them from left to right. Note that division cannot occur until there is a single number in the numerator and a single number in the denominator. You'll often see it separated by the division bar. Finally, the last step in the order of operations is subtraction and addition. These are also of the same importance, and you evaluate these from left to right. Moving on, it says leave your answers as fractions instead of decimals. They are more precise. Then, I have a note here with some caution against PEMDAS. Many of you may have seen this as you are learning the order of operations in elementary school. The cautions I have against using PEMDAS is parentheses. They can mean many things in math expressions. They can be a grouping symbol, as we saw above. It could also indicate an open interval if you're talking about the features of a function. They can mean multiplication. They can also be put around a number to show that it is a negative integer. And parentheses also are used in ordered pairs. So when you see P and you think parentheses, you've got to evaluate what do the parentheses mean in this specific problem. Next, since exponents are just repeated multiplication, they do not actually need a separate line from the division and multiplication, and just remember that the commutative property applies. The commutative property means that you can multiply in any order and get the correct result. Another caution with PEMDAS is many students always want to multiply before dividing because they see the M in front of the D. Or they want to add before subtracting because they see the A in front of the S. But you will sometimes get the problems incorrect this way. So we're going to be checking off these steps from the orders of operations on each problem as we do. Let's proceed to example 1. You can pause this video at any time before the answer is revealed, but check off the steps for the order of operations as you complete them. Example 1. We have 26 subtract 27 divided by 3. According to the order of operations, we need to first check for grouping symbols. We do not have any grouping symbols in this problem, so we can move on. Next comes exponents. Again, there are no exponents in this problem, so we can move on. The next on our list is division and multiplication. We do them in order from left to right. Since the only operation that we see out of those is division, we need to perform this division first. 27 divided by 3 is 9. We write down 26 and the subtraction symbol because all we've done is evaluated the first of our operations. Now that we have that division and there's no multiplication, we can proceed to the last step, which is subtraction and addition. The only one we have here is subtraction. 26 subtract 9 is 17. And we have completed that problem. Moving on to example 2. We need to look for first grouping symbols. In this problem, we actually do not have any grouping symbols. There are a bunch of parentheses, but as cautioned earlier, parentheses can mean many different things in mathematics. These parentheses indicate multiplication is happening here. These parentheses show that this is a negative number, -5. These parentheses also indicate a negative integer, -4. These parentheses are here to show multiplication as well. So, grouping symbols, since there are none, and exponents, again, there are none in this problem, we can proceed with the multiplication and division from left to right. We just have multiplication, no division in this problem, and so first we'll multiply 3 times -5, which is -15. We'll keep it in parentheses for now, and then move on to the next one, which is -4 times 2, which is -8. Also keeping that number in parentheses for now to show that it is a negative integer. The operation addition has not been dealt with, so we bring down the addition symbol to our next line. From here, we have no more division or multiplication, so we can move to the last step, which is addition. A -15 plus a -8 is going to equal -23. When you have negative numbers and you add them together, your answer remains negative. Example 3. We have 3 plus 5 and then parentheses 8 subtract 2 and the parentheses get closed. Starting from the top of our checklist. First is grouping symbols. The parentheses in this case are a grouping symbol. We need to perform the operation there to begin. 8 subtract 2 is in parentheses and the answer is 6. We're going to keep that number in parentheses and carry down the rest of the problem. These parentheses no longer act as a grouping symbol. They are now indicating the operation of multiplication. 5 was being multiplied by what was inside the parentheses, the same as the 5 here was being multiplied by what's in the parentheses above. Next, after grouping symbols, exponents. There are no exponents in example 3. After exponents comes division and multiplication. We have no division, but then the 5 and the 6 separated by parentheses indicates multiplication. So the 3 will remain, as well as the additional sign. 5 multiplied by 6 is 30. In this final part of the problem, the only operation is addition. 3 plus 30 is 33 is the final answer. And then example 4. In example 4, we have 18 divided by 2, and then the dot indicating multiplication, and 3. In this problem, there are no grouping symbols, nor are there any exponents. So the next part of the order of operations is division and multiplication. We need to do these in order from left to right. The division symbol is to the left of the multiplication symbol, so these two numbers need to be divided before we do the multiplication. 18 divided by 2 is 9. Carry down the multiplication dot and the 3. Now that the division is done, we can now do the multiplication. 9 multiplied by 3 is 27. 27 is the correct answer. Now here I'm going to show you the incorrect way of solving this problem. Okay? When students do this incorrectly, if they do the multiplication before the division, then they will multiply 2 times 3 and get 18 divided by 6. 18 divided by 6 is 3, but this is incorrect. That was just a quick way of showing what some students will do incorrectly and get an answer that looks like it may make sense. However, they did not follow the proper order of operations. Moving on. Let's go to example 5. Example 5, we start at the order of operations. First, we have to look for grouping symbols. In this case, we do have a unique grouping symbol. These up and down lines here indicate that the absolute value is in play. First, we need to evaluate what is inside the grouping symbol. 5 subtract 9. 5 is a smaller number than 9. When you subtract, you are left with a negative number. 5 subtract 9 is negative 4, and we'll keep it in the grouping symbols, as well as the other pieces, 2, the addition symbol, and the 3. Now that this in the grouping symbol is down to one single number, we need to perform the absolute value operation. Absolute value is the distance a number is from 0. Negative 4 is 4 spaces away from 0. Therefore, absolute value symbols take a negative number and turn it into a positive. Absolute value symbols will leave a positive number as a positive. We can write down the 3 plus 2, and now that we're performing the absolute value operation, negative 4 will become 4, but we will switch that now to parentheses. The parentheses in this case are not a grouping symbol, but now they can indicate that 2 is being multiplied by the 4. Next, we don't have any exponents. Our grouping symbols are down to one number, so we can proceed to division and multiplication. No division symbols. We do have multiplication. 2 times 4 is 8. And we have 3 plus 8 carried down to the next step. After that, we move on to subtraction and addition. 3 plus 8 equals 11. Example 6. In example 6, we first need to look for grouping symbols. In this problem, we do have a grouping symbol, parentheses around the 6 subtract 2. We will take the 6 subtract 2 and make that 4. 6 subtract 2 is 4. Leave it in parentheses. The 5 stays right beside the parentheses and now indicates multiplication. We have addition 2 to the third power and the other addition with the 4. Now that the grouping symbols have finished, we can move on to exponents. This is our first interaction with exponents. Right here we have a base and an exponent, and the entire term is called a power. This is read as 2 to the power of 3. What this means is that the base of 2 gets multiplied 3 times. That is 2 times 2 times 2. 2 times 2 is 4, multiplied by a third 2 is 8. 4 plus 8 plus 5, parentheses 4. Our exponents have been taken care of, so we can move on to division and multiplication. The only multiplication or division we see is the 5 multiplied by 4, which is 20. Four plus 8 plus 20 is all that remains. We should do the addition from left to right as our final step. There is no subtraction, but in this case, when there is only addition, the commutative property applies that we could actually add these in any order and still get the same result. 4 plus 8 is 12, added to 20 equals 32. Example 7. In example 7, we need to first look for grouping symbols. We see parentheses, but the parentheses here only indicate multiplication between the 5 and the 3, and the parentheses down here indicate multiplication between the 2 and the 5. There are no visible grouping symbols in this problem. However, we do have invisible grouping symbols, as mentioned on our definitions page, between the numerator and the denominator. I am drawing in those grouping symbols. We cannot perform this operation of division with the bar until we get a single number in the numerator and a single number in the denominator. So, in the numerator, we have 5 multiplied by 3, which is 15. Subtract 12. Include the division bar. In the denominator, we have 4 subtract 2 multiplied by 5. Since inside this invisible grouping symbol the multiplication needs to happen first, we will get 4 subtract 10. There are still invisible grouping symbols around the numerator and the denominator. We proceed by evaluating 15 subtract 12, which is 3. Include the division bar, and then 4 subtract 10, which is negative 6. Since 4 is a smaller number than 10, our result is a negative number. We now have just a single number in the numerator and a single number in the denominator. Now we can perform the other operations. There were no exponents. Now we can do our division. This indicates division. 3 divides into groups of negative 6. A positive divided by a negative is going to be a negative number, but 3 is smaller than 6, so we will get a fraction. These can reduce. 3 can be divided by 3, and so can 6. We'll get a negative result, and 3 divided by 3 is 1. Negative 6 divided by 3 is 2, and the negative sign here. Our answer is negative 1/2. We want to leave this as a fraction rather than changing it to a decimal. Example 8. In this one, we need to first look at our grouping symbols. We have two sets of grouping symbols in this one. We've got the square, brackets, and parentheses. With this, when you have multiple sets of grouping symbols, you need to work from the inside until this gets down to one single number, and then we'll deal with anything on the outside of the brackets. So the 2 on the outside of this bracket will need to remain until a later step. On the inside of the brackets, we need to look at the order of operations again, specifically for what's on the inside. First, we need to do grouping symbols. We do have this grouping symbol of parentheses, so this gets evaluated first. 1 subtract 3 is negative 2. We'll keep that in parentheses, and the exponent, the 4, and the subtraction symbol, and the 3. Next, these parentheses are no longer a grouping symbol, and we need to move to exponents. We do have an exponent. The exponent is attached to just what is on the inside of the parentheses. That means negative 2 needs to be multiplied by itself. A negative times a negative is going to be a positive. We can write down that negative 2 and negative 2 are going to be multiplied by each other and provide a result of a positive 4. A negative times a negative is a positive. The exponents are no longer inside the brackets. Now we just have the operations of subtraction and multiplication. Multiplication needs to happen first. Leave the 2 and the brackets. The 3 and the subtraction have to come after 4 multiplied by 4, which is 16. We're down to one of the final steps. 3 subtract 16 in the brackets is negative 13. The brackets can now become parentheses, the 2 on the outside indicating multiplication, and our final step is 2 multiplied by negative 13, which is negative 26. There were many steps in this problem, but in order to achieve the correct answer, we followed the order of operations. The last order of operations example, example 9. In this one, we have a grouping symbol here with the parentheses. These parentheses just indicate multiplication. 5 plus 6 becomes 11. We'll keep it in parentheses, with the 3 on the outside also now indicating multiplication. Bring down the subtraction symbol, and 4 and the 3 in parentheses also are indicating multiplication. Next, there are no exponents. There is no division, so we can now just do the multiplication. 3 multiplied by 11 is 33. Subtract, and 4 multiplied by 3 is 12. Both of the multiplications needed to happen before the subtraction. The last one is addition and subtraction from left to right, but we only have the operation of subtraction. 33 subtract 12 is 21. This is the end of the section on order of operations.